Take a look at this compact yet powerful mini excavator, a fully functional, manually operated robotic arm designed to mimic the working of a real-life construction excavator, just like the original machines used on construction sites. Though it's small in size, it's capable of picking up and placing small objects or components with precision. Its functionality is mighty. The entire system is powered by an Arduino Uno paired with a robot shield, which together control multiple servo motors, allowing for realistic and flexible movements. If you want to take this project a step further, you can easily enhance it by adding smart sensors like ultrasonic sensors for obstacle detection. With these upgrades, so now let's begin the actual making process. To build this manually controlled excavator robot arm quality servo motors, I've used 4 10K potentiometers. Next, I added the Arduino Uno as the brain of the system. I used a robotic shield on top of the Arduino. I've also used a few wooden sticks in this project to support the structure and give it a more DIY touch. I took a lightweight but strong acrylic sheet as the base. I applied hot glue carefully to fix the servo motors on the sheet in their respective positions. The placement was done with proper alignment to ensure the robotic arm could function just like a miniature construction excavator. Friends, this step is super important, because how accurately you fit each servo motor will directly affect how smoothly your robotic arm performs. So I'm carefully placing and installing each servo motor step by step, and I'll guide you through it. For this, I used a simple plastic stick, but here's the fun part. I slightly heated the stick using a lighter to make it flexible. Once warm, I carefully bent it into a specific shape that could mimic the movement of a real hydraulic arm joint. This shade stick acts as a link or bridge between the servo motor and the gripping or lifting part of the arm. Once it cooled and held its form, I securely fitted it with the servo horn using screws and glue. Once the mechanical part was in place, I took an Arduino Uno, which is the central microcontroller responsible for reading input signals. I connected a robotic shield on top of the Arduino Uno. It provides dedicated servo slots, power handling, and cleaner connection points. Now let's move ahead to mounting and wiring the potentiometers. I used 4 10K potentiometers, which are basically variable resistors that act like custom joysticks in this project. I took each potentiometer and carefully fixed it onto the base sheet using hot glue. I did this one by one, ensuring proper spacing and alignment, so that the controls would be easy to operate without crowding. These sticks act like mini control levers, allowing you to rotate the potentiometers easily and with better grip. Once the physical setup was done, I moved on to the electrical connections. Now that all the potentiometers are firmly fixed in place, it's time to complete their wiring connections. To make things even easier for you, I've included a complete wiring diagram for reference. You can either follow the same connections I made, or modify them based on your setup. So now friends, let's move ahead and dive into the most exciting part, the programming phase of our manually controlled robotic excavator arm. I've already written and uploaded the necessary Arduino code, and don't worry, I've included the complete code and details in the description section below. You can simply copy it from there and upload it to your Arduino Uno. Once the code was successfully uploaded, now comes the real test. Let's check how it performs in real time. As I gently move the sticks attached to the potentiometers, you can clearly see the servo motors responding smoothly. The robotic arm moves just the way it was intended to, with accuracy, control, and zero lag. Whether it's lifting, rotating, or gripping, by actually lifting and moving a few objects with it, I've placed some small weight items in front of the excavator, and now I'll use the manual control sticks, the potentiometers, to operate each movement. As you can see, the arm responds beautifully. Every joint, from the base rotation to the elbow and gripper, moves with great precision, just like the real deal. Watching it in action is truly satisfying. This compact machine has been designed with real engineering principles in mind. In fact, in large construction companies and industrial environments, the same type of robotic arms and excavators are used, but on a much bigger scale and with more advanced systems. So how did you like this DIY excavator project? Make sure to let me know your thoughts in the comments section below. That's it for today's video, friends. We'll meet again in the next one with something even more exciting. Until then, take care, stay creative.